Welcome to Sundar's lecture. This is lecture number 96, and in this lecture we are going to see some more problems related to star and then also delta connected system to get a good clarity about the derivation whatever we have derived in the star and delta connections, right? So what are the topics we have seen in the previous class? See, we have started with the delta connected problems, and we have also seen what is the star delta equivalence. You can just convert the star to delta or delta to star. You can do that, and you can replace the equation impedances with this particular equation. ZY can be written as Z delta divided by 3, right? So we have solved another problem to get an idea, and now in this class we will see some more complicated problems, maybe the understanding level problems, right? So we have, this is the first problem. First one, see, a balanced star connected load with Z is equal to 65 at an angle of minus 20 degree is connected to a three-phase, three-wire CBA system where VAB is equal to 678.8 at an angle of minus 120 degree. Then we need to find the three line currents, right? This is the question they have given you. See, this one you have to be very careful that this system is not ABC system. It won't follow the ABC sequence. It will follow the CBA sequence. So what you have to do here? See, they have given you VAB, right? This is VAB. There is no issues with that. They have given you that is 678.8 at an angle of minus 120 degree volt, right? This is the value they have given you, and also they have given you Z value, that is balanced load. So all the Z value will be the same one. So this is the two given data, and they have given you it is a CBA system. If it is CBA system, then you see I have to draw the diagram to get you good knowledge, because you see if I take this is C, and because I have to take this as reference, so C, right? So I have to take C as reference. So you see this is BC, C, and then it will come B, and then you have to write A. Try to understand. That is what they have given you, right? So these are all phase voltages. These are all phase voltages, and if I need to find what is the value of VAB, then what I have to do? I have to take this one. I have to take this minus VB. This is minus VB, right? This is minus VB, and if I add these two, I will obviously get what? This is nothing but VAB. This is nothing but VAB, right? If I add these two, I will get VAB. This is the graph now. And now you have to be very careful here, because you see, if I come in this clockwise direction, VA comes first and then VAB comes next. So if we know, right, this degree will be 30 degree, and we know everything, those kind of things, and all. It is not a big problem for us. This will be 30 degree, right? So VA comes first, VAB comes next. So what you have to write here now, we know, right, what is the formula? If it is VA, then it is a phase voltage, right? So now if you want a phase voltage, then it will be VAB, this is the line voltage, divided by root 3 times, and you see this leads the VAB by 30 degree, right? This leads the VAB by 30 degree, and this angle should be whatever the angle you get here, that is minus 120 is already there, it is already there, plus 30 degree. Try to understand. That is what it is very important to draw the diagram, and then you have to understand, right? So now if you want to simplify this VA can be now written as 678.8 divided by root 3 at an angle of minus 90 degree, right? You will get minus 90 degree, and if I simplify this, then I will get VA to be, I'm just getting it to be 391.9 at an angle of minus 90 degree volt. Minus 90 degree volt. Now it is very simple, right? Because you can easily find what is the value of IA. What is the value of IA? That is what they are asking you, right? You need to find what is IA, IB, and then IC, right? So if you want to find what is the value of IA, then it is VA divided by what? Is it? Simply you can put this value, right? So what is VA? It is 391.9 at an angle of minus 90 degree. That is already there, divided by what is the Z value? It is 65 at an angle of minus 20 degree, right? Yes, minus 20 degree. And if I simplify this, I will get IA. I'm just getting, you just simplify this. I'm just getting it to be 6.03 at an angle of minus 70 degree. If you bring this to the numerator and all those kind of things you already know. See, if this is A, try to understand one thing here. You know now what is A? What is the system now? It is CBA, right? You know, right? It is CBA, and you know this value. Maybe the current. Maybe I will draw here the current one. This one, and then this one, right? So if this is IA, see this is if this is IC, this is CBA, right? So now this is the value. What is this angle? This angle is plus 120 degree. Plus 120 degree. I can write like this, right? Because this is minus 120, minus 240. I can write from here to here it is minus 240, or I can write it as plus 120. That is also correct, right? So what I can write? What can be the IC value? The value it will be same. The magnitude value it will be same, plus 120. What will you get if you put plus 120 degree to this value? Plus 120, so it will be 50 degree, right? Am I right? I see. Anyhow, 1 minute. You see, I will tell it in another way because the answers given are in that way. So I will tell you in that way. See, this one we have now, right? So I will find what is the value of IC now. So what you will get from here, if you go here, what is the value? What is this value? It is plus 240, right? From here to here it will be minus 240. From here to here it will be plus 240, right? So minus 70 plus 240. What I have to say, minus 70 plus 240, you will get what? That is nothing but 170 degree, right? So next one, IB. That is also very simple. See, you know now IC, right? You know IC. Now, if you want to find the value of IB, then the angle, if I go in this way, this is minus 120 degree. Simple, minus 120. From here to here, it will be minus 120. So, what I will get here? Simply, I can write it as 6.03. From here, minus 170 plus 170 minus 120, it will be 50 degree. That's all. Now, you see these three answers. A option A is the correct answer. Option A is the correct answer, right? IA, you will get this value. IB, you will get IB, you will get 50 degree, and IC, you will get 170 degree, right? So now we have solved this problem, and we will move on to the next problem. See, try to understand one thing. You just draw this diagram. That is very important. You have to draw this diagram to get at which angle the phase voltages and line voltages are apart. That is very important. Try to understand and try to develop your skills in drawing the phasor diagrams, and then find the angle between the phase and line voltages, right? So we will move on to the next one. So now you see this is the second problem, and in the second problem what they have given you, a balanced delta connected load having an impedance of 15.J25 ohms is connected to a three-phase generator with VAB. They have given you VAB value, so I can write it here. VAB, which is equal to 200 at an angle of 0 degree volt. So this is the reference, right? Now VAB will be the reference, and calculate the load side phase and line currents. The sequence is ABC. They have given you ABC sequence. So right, they have asked you to find what is the phase and line current. So what I can do now? Now I can go for IAB. What is IAB? It is 200 at an angle of 0 degree. Maybe I will write the formula anyhow for one thing. So VAB divided by Z. Very simple, right? Because they have already given you this value. So what is this one now? It is 200 at an angle of 0 degree divided by, and if I convert this value 15 plus j 25 ohms, I'm just getting 29.15 at an angle of 59.04 degree. I'm just getting this one. So finally, if I write this value, then IAB will be is equal to, if I simplify this, I am getting 6.86 at an angle of 6.86 at an angle of minus 59.04 degree volt amperes, right? So this is the value I am just getting. So what will be now IA, IBC, because this is ABC sequence. So IBC will be 6.89 at an angle of minus 59.04 minus 120 degree, right? Minus 120 degree. So I am getting minus 179.04 amperes. And then ICA, what will be the value of ICA, and that will be also same magnitude, 6.86, and from here on it will be minus 240 degree, or I can go for plus 120 degree, right? So if I put plus 120 degree, then I will get 60.69 degree amperes. See, this is the value you will get. Maybe some calculation errors may be there, because if you put exactly plus 120 here, it is 96, right? I have made a mistake. This is 96 degree, right? So now maybe this is the values we have found. What is the phase currents, right? These are all phase currents. I have found what is the phase current. And now if I want to find what is the line current, then what I have to do, it is very simple, right? We know the formulas anyhow. If I want to find what is IA, what is IA? What is the formula for finding out IA? Simply you can write it as IAB minus ICA, right? So if I substitute this values, what is IAB? It is 6.86 at an angle of minus 59.04 degree, minus ICA, it is 6.86 at an angle of 60.96 degree, right? So if I simplify this, then I am getting IA to be IA, I am just getting it to be 11.88 at an angle of minus 89.04 degree amperes. So now you know IA, right? So it will be very easy. What is the value will be? What is the value for IB? It will be again 11.88. From here on, you have to put minus 120 degree. From here on, you have to put minus 120. What will be the value for if I put minus 120? So it will be minus 209.04 degree amperes. And then if I am going for IC, then the magnitude will be same, right? From here on I have to put plus 120 degree, or I can put minus 240 degree, anything it may be. So I will put plus 120 degree from here on. So I am just getting plus 30.96 degree amperes. So now we have found the phase voltages. These are all phase voltages, right? These are all phase voltages, and these are all line voltages. We have found both the values. Very simple. Maybe you can go in a different way too, because if this is the phase current, right? What will you get if this is the phase current? Then what is the line? This is line. This is phase current, right? What will be the line current? Line current will be root 3 times, simply. So you can put root 3 here, and also the line current lags the phase current by 30 degree in ABC sequence. If you know this value, then it not necessary to put these kind of formulas. That is also possible. Try to understand. You do that by yourself, because we have learned so many things in the previous class, right? So now we will go to the next problem. And now you see, this is problem number 3, and for the circuit, considering VA as the reference voltage, compute each line voltage at the load side and line current, phase current in the loads, both magnitude and angles, right? The phase sequence they have given you, that this is ABC. See, try to understand one thing. They have given this circuit, right? This is the circuit. See, where we can apply the delta star equivalents, that is very important here, because we know, right, we have already derived the equation zy will be is equal to z delta divided by 3 times, right? So now we know this one already. See, this is given question, this is the given question, and this is the generation side and this is the load side, right? Now it is very complicated to find the line voltages, phase voltages, line current, phase current in the load side if we have star in the generation side, delta in the load side. So what we are going to do now, because all the impedances are same, this is 9 at an angle of 20, 9 at an angle of 20, 9 at an angle of 20, what I am going to do, I am just going to convert this delta into star. See, that is what I have done here. Point, you just take these 3 points, across these 3 points I can convert this delta into a equivalent star connection by this equation, right? By this equation, right? Star, you just divide the magnitude by 3, you will get the equivalent impedance, right? I have just done this one. Now it is very simple to find the values. See one thing, because why I am saying this one, see, this is neutral point, this is to a neutral point, right? So if I draw the diagram, maybe I will draw you, because that is why you can easily understand. See, this is VAN, I am just taking this point as N, right? This point as N, and there is an impedance here, there is an impedance here, and this impedance is here, this impedance is here. So I just try to explain you things with the basics we have already seen, right? So now this is VAN, right? This is VAN, and they have given you this value. This value already given, that is 120 at an angle of 0 degree, right? VAN is already given, that is 120 at an angle of 0 degree volt, right? So what is this one now? 2 plus J 4 ohms, and what is this value? It is 3 at an angle of 20 degree, right? Ohms. So now this is the diagram we know because we have neutral point, we can draw like this. And now what I have to do, what is the load side VAN? What is load side VAN? This is load side VAN, right? This is generation side, try to understand, this is generation side, and maybe I I will put the different value VA, let it be VA, because you can easily discriminate between what is the generation side, it is VAN, load side it is VA. Then what is the value of VA? Very simple, you use the voltage division rule, and now you know what is this value, right? Total voltage, that is 120 degree, 120 at an angle of 0, I don't need to put at an angle of 0 degree, multiplication of that particular resistance value, that is 3 at an angle of 20 degree, divided by total resistance. Total resistance 2 plus J4, this is one value, plus 3 at an angle of 20 degree, right? So now you see, this is the load side phase voltage, whatever I am getting it right now here. See, I am just getting VA. If I simplify this value, I am getting VA to be 51.7, 51.7 at an angle of minus 26.2 degree volt. Simply we have found, what is the value of VA, right? VA, this one, across these 2 points I am just taking it to be VA to discriminate the difference between load side and the generation side. Generation side I have taken VA, try to understand, right? Now from here on I can easily find what is the values. Since this is ABC sequence, right? Since this is ABC sequence they have given you, so what will be VB? What will be VB? Same magnitude 51.7 at an angle of minus 26.2 degree, minus 120 degree. So what I will get here, it will be minus 146.2 degree volt, right? Very simple, right? So VC, that is phase C voltage, same magnitude 51.7 degree at an angle of, you just try to understand, put plus 120 degree here. If I put plus 120 degree here, what I will get? Plus 120 degree, so I will get 93.8 degree volt, plus 93.8 degree volt. Simply we have found what is the values, right? Now if you want to find what is this current? Because you see this current, this is nothing but I will take it as IA. Whatever the current flowing here, I am just taking it to be IA. That is the phase current here because this is a star connection, right? So phase current. So I can write this as now IA. What will be IA? Again it is simple. See, if I go for IA, then the voltage value, that is 120 at an angle of 0 degree, divided by total resistance value. What is total resistance? It is 3 at an angle of 20 degree plus 2 plus 4 j ohms, right? This is the formula to find the value of IA. So if I do so, I am getting IA to be, what is the value of IA? It is a 17.23 at an angle of 17.23 at an angle of minus 46.2 degree volt. Sorry, not volt, it is amperes. So again it is ABC sequence. So what I can write here, IB can be written as the same magnitude value, that is 17.23 at an angle of minus 120 degree. From here on it is minus 120 degree, so it will be minus 166.2 degree amperes. And if I go so, now I need to go for IC. What will be IC? Again the magnitude will be same, 17.23 at an angle of, from here on, plus 120 degree. If I put plus 120 degree in this value, plus 120, what I will get? I am just getting 73.8 degree, 8 degree amperes. So now we have found all the values, right? What is the values now? So IA, IB, IC, that is VA, VB, VC, we have found. And because this is star connection, how will you find VAB? VAB, that is the line voltage, right? So line voltage formula, it is VA minus VB. So if I substitute VA, what is the value of VA? It is 51.7 at an angle of minus 26.2 degree, minus, what is VB? It is 51.7 at an angle of minus 146.2 degree, right? So if I simplify this value, that is VAB, these are all line voltages. VAB, I am just getting it to be 89.55 at an angle of 3.8 degree volt. See, try to understand very simply here because I don't need to do this. If I know what is the phase voltage, very simple to find what is the line voltage, right? Root 3 times, you just multiply it with root 3, you will get this value, plus 30 degree. Plus 30 degree, you will get easily this value, right? So anyhow, I have just found like this. And then VBC, the same magnitude, 89.55. From here, it is minus 120 degree. So if I put minus 120 degree, so it will be minus 116.2 degree volt. And then if I go for VCA, because this is ABC sequence, again the value will be, magnitude value will be same, 89.55. From here on, it will be plus 120 degree. What I have done, yes, it is plus 120 degree. If I put plus 120 degree, it is 123.8 degree volt. Now we found the values of line voltages, right? Now it is very simple to find what is the line currents, right? What is the line currents? Maybe I will take it to the next page. See, one thing, what we have found, see, we have found this IA, IB, IC, right? Now you see, we have just converted this one like this, but they are asking you to find what is the line and phase currents of this particular delta connection, and we need to find what is the value of IA, IB, and then IC. So sorry, IAB, IBC, and then ICA. How will you find IAB, IBC, and ICA? And we know what is VAB now, and from here on you can do for you can go for IAB, that is VAB divided by what? This 9 at an angle of 20 degree. Try to understand. That is why this Z value here to find this value, see, try to understand, we are going to find what is IAB, IBC, ICA, and we know what is VAB, VBC, VCA. See, line voltages here will be same in the delta connection, in the star connection, whatever it may be, right? So what we need to find, this is at, now it will be 9 at an angle of 20 degree to find the values of IAB, right? IAB, which means this value, this is IAB, right? Not here, no IAB will come here. Try to understand that one clearly, right? So if I want to find what is IAB, then it will be VAB divided by the Z value, and we need to find, that is in delta connected Z value, and we need to find, this is 8.95, right? As it is 89.55 at an angle of 3.88 degree, whole divided by 9 at an angle of 20 degree, right? So if I simplify this value, I am just getting the value of IAB to be, I am just getting it to be 9.95 at an angle of minus 16.2 degree amperes. And we know the sequence they have given you, that is ABC, so IBC will be 9.95, same magnitude, at an angle of minus 120 degree from here on, so it will be minus 136.35 degree amperes. And ICA, if you are going from here on, it is 9.95 at an angle of, you just put a plus 120 degree in this equation, in this angle, so you will get 103.8 degree amperes. Now see, for this problem, for this diagram, we have found what is the value of VAB, VBC and VCA, and we have found what is the values of IAB, IBC and ICA, and also IA, IB, IC. Line voltages, line currents, and phase voltages, everything we have found. See, try to understand one thing. If you see any problems like this, you try to convert that into star to find the values of the line voltages. Then it is very easy to find the values of line currents and phase currents from here, right? So you just go through these problems. We will see in the next class. Thank you. We will start a new topic in the next class.